A, B, C, D, E, F. And it says here, it's supported by bearings at C and D, and by the wire at AH. And it says, knowing that portion AB of the rod is 250 millimeters long. So it's the same as this one, isn't it? Up here, it's just bent up. It says determine the tension in wire AH. When I remove the wire, right? Free body diagram. I'm doing a free body diagram of this bent rod. And the reactions at C and D. Assume the bearing D does not exert axial thrust. That means this only has a J and a K force, right? Support reaction associated with this one. This one has all of them. So here you'd have, I'm just going to put it in positive, CY, positive CX, and that doesn't look so good. Let's do that. CZ, and this one's going to have a DZ and a DY only. Right? And it's going to have that 400 Newton force acting down. Everything I drew in dry erase is pretty much your free body diagram. And, geez, how are we gonna, okay. I'm just looking at this because I want to reduce this with its unit vector, right? And then sum the moments. You know what? I could sum, with respect to this point, I can use the law of transmissibility, right? And I can move these component forces anywhere along that line because I know that that follows our nodule, right? Its component moments have to be the same as its result moment. So what if that's 30 degrees, right? So what if I run a parallel line like this to here? This has got to be 30 degrees then. And that's perpendicular. That's perpendicular, so this has to be 60. And if that's 30 and 60, this has to be 60, and that means that this is 30. And that would make sense if this, yes, that's 250, so this makes sense. The first thing I would do here is, now that I drew my free body diagram, is exactly what we just did a minute ago. Put everything in its rectangular components. I don't have to use the unit vector here though, do I? I can literally just say that T is equal to, it's got a J and a TK, right? And the J component is going to be cosine of 30. T cosine of 30 degrees, and it's, you know what? I'm going to do it the other way. I want to show the I hat first. Sine of 30, J hat first. And it's positive, right? T sine of 30, J hat, and minus T cosine of 30 K hat. Make sense? All I did was reduce it to its rectangular components, right? And to solve for this thing, we have sum of the forces. There's too many of those, right? So we have the only other equations that we can have is the sum of the moments. And that doesn't have an X, right? I guess it doesn't matter. We can use either one. I'm going to sum the moments at C. All right? And then now that I have two unknowns, I got two equations, two unknowns. I'm going to sum the moments at C, and we'll find dy and dz. And then from there, I can come back and use the sum of the forces of x, y, and z to find the only left unknowns, right? It'll also find the tensile force too, because I have three equations. I'll have an I, J, and a K with respect to here. I'm definitely doing that. All right, sum of the moments at C. That's equal to 0. 0 is equal to the position vectors are, like I said before, we'll do it from here. Right? It'll have that, and it'll have this force. R H respect to C cross T plus R D with respect to C cross, I guess I'll just call this D. Right? We don't have anything going on there. There's nothing I can do to resolve anything here. And then we have plus R F with respect to C cross, what is it, 900 newtons? Is that 9? Is that a 4? 4. Could read my handwriting. 400 newtons acting down. Negative 400 newtons J hat. So far, so good? Let's write down our position vectors. R H with respect to C is equal to what? With respect to C, to get to here, I have negative 50I, right? And it already told us that this is plus 250J. Negative 50 millimeters I plus 250 millimeters J hat. And then we have D with respect to C, right? R D with respect to C is just 300 millimeters, right? I hat, positive. 300 millimeters I hat. And then we have R F with respect to C, which is 350 positive, and then 250 positive K. So it's 350 millimeters positive I hat plus 250 millimeters positive K hat. So far, so good? All right, let's write out our three determinants. 0 is equal to I, J, K. H with respect to C is negative 50I plus 250J. 0. And T is equal to, it's got J and K, right? So that's 0. And this is, I'm just going to put sine of 30 in here. And I'm going to put cosine of 30 here. And I'll pull out the constant T, right? And then I do the same I, J, K. RD with respect to C is just 300I. 0, 0. D is unknown dy and unknown dz. I put 0, dy, dz. Right? What's the last one? F is 350I. 350I plus 250K, right? And negative 400J. 0, negative 400, 0. I just resolve all the determinants, combine the like times, right? I's, J's, and K's. That I'm not going to do by hand here. Takes too long, right? But I'm gonna do it. I'm gonna write it out. So combining I, J's, and K's. You have I hat negative 216.5 T plus 100 times 10 to the third is equal to 0. So essentially, T is solvable, right? 461.9 newtons, or 462 newtons, 3 significant digits. So we got T, and now we can get the two reactions at D, because we have I, J, and K. J hat is equal to negative 43.3 T minus 300 DZ. Does that make sense? It does. DZ times 300, and it's gonna rotate down. I just usually look at 1 and 2 like that, just to check it. So I know it's right. And that's all equal to 0. Substitute in 461.9 into T, right? And we solve for DZ, and DZ winds up being equal to negative 66.7 newtons. Did I even solve for C? I did. Okay, good. And then we do K hat. And that's just equal to negative 25 T when I resolve that, right, in terms of K. And then we've got 300 dy, definitely positive, that's a T. 300 dy minus 140 times 10 to the third is equal to 0. Yeah, good. When I substitute into T, 461.9, I can now solve for dy. Where dy is equal to 505 newtons. Positive, right? Acting up. All right, so we got T, and we got the support reactions of dy and dz, right? There is no dx because it does not exert axial thrust. If there was a dx, then we'd have another, right? It may be a little bit more complicated. We'd have to solve 3 equations, 3 unknowns, which wouldn't be fun. At first I thought, oh man, maybe we do have to do this if we had the sum of moment here, but we don't have to, right? So, we got that. And now we have to find the reaction at C. Cx, Cy, and Cz. And we can do that using E. Exactly. Segment equals 0. Equilibrium, right? Summation of forces of x is equal to 0. 0 is equal to Cx positive plus what other x forces we have, right? And we have, well, we don't have a dx. T doesn't have an x, so that's it. Answer. Sum of the forces of y is equal to 0. Well, we do have a dy, right? And it's 505 up, and we have cy. 0 is equal to cy plus 505 newtons acting up, plus 400 newtons acting down, right? 400 newtons acting down, plus the vertical force, vertical component force of T, right? Which is, T is 461.9 sine to 30, right? And that's acting up 461.9 newtons sine to 30, which is basically 0.5. And that's positive. Solve for Cy, and you should get 336 newtons negative, which is 336 newtons acting down. And now sum of the forces of Z is equal to 0. And that's it. 0 is equal to CZ plus DZ, which is negative 66.7. Negative 66.7 newtons, plus the Z component of that tensile force in the cable. 461.9 cosine 30. Negative. Solve for ZZ, and you're going to get a positive answer of 467 newtons. That's that. That's all she wrote, folks. It's really not much different, was it, than the other problem? Still involves a lot of different skill sets though, right? It's the critical thinking skills. That free body diagram, right? Translating it into this, understanding, right, summing the moments with respect to a point. Knowing that if I summed it here, I have 1, 2, 3 unknowns, and I would have 3 separate equations, right, to solve for them. If I sum the moments at D, I have 1, 2, 3, 4 unknowns. The 3 equations. Even though I would have looked at it, said Cx is equal to 0 and knocked it out anyway. But. What do you think? Good. That's it. That's all she wrote. Chapter 4 is done. So I'll have the test on Thursday. Like I said, it'll be 4 or potentially 5 problems. Don't show up late. That'll be a big mistake. You just put undue pressure on yourselves to complete it. And we're going to move on right along.